Hi, welcome. Please get your notes out. I'm going to go ahead and share. So we get started on day when we don't have any power on campus. Okay, 6 trig functions. You're not going to be in a right triangle anymore. These are Comey's notes for November 7th, 2023. So far, we've defined the 6 trig functions for our geometry. We know angles can be measured in either degrees or in radians. In geometry, we always assume that theta was an acute angle in a right triangle, which meant the terminal side would have to be in the first quadrant. But most times we didn't even draw the x and y axis, we just drew a right triangle. And all our trig functions were positive. But now we're going to refine our definition to include any angle drawn in standard position. And to do this, we need to recall the equation of a circle centered at the origin. You've been asked several times in the last homework to find the equation of a circle centered at the origin. And to recall what that is, it's x squared plus y squared equals r squared. Our new definitions, which really aren't new, they are old definitions. Let theta be any angle in standard position. Let point P be any point x comma y different from the origin. So point P can't be at the origin. Not if you want to have a distance from the origin. And it has to be on the terminal side of angle theta. And let the distance from P to the origin be r. So let me go ahead and show you what I have. I've got a circle and I've got my initial ray on the positive x-axis where initial ray should always start, and I need a terminal side. And so I'm going to actually draw my angle. Let me use my terminal side. I'm going to put my angle in quadrant 2. So my terminal side, let me move it away from the y-axis a little bit. There we go. And the way that we draw our angle is we don't just label it with our angle theta. We actually have a sweeping arc. Let me see if I've got an arc here. Indicating the amount of rotation we have. And our point P is on the terminal side of your angle theta. And I'm going to put it down on the circle because I want the distance from the origin to, so the distance from the origin to my point P, I want this distance to be r, which is the radius of the circle. Instead of computing the distance formula, what I could do is I can just go ahead and take the square root of both sides of x squared plus y squared equals r squared, which is my equation of my circle, which is up here. Take the square root of both sides, or again, think of it as a distance formula, and that r is the square root of x squared plus y squared. The sine of our angle theta is still going to be called y over r. It's what it was to begin with. It's still what it is today. Our cosine will still be x over r. And our tangent is going to be y over x. Again, these were the same definitions I gave you when we originally defined our trig ratios. But then I went in and said, you know what, we'll look at sine as being the SOHCAHTOA, opposite over hypotenuse, cosine be the adjacent over hypotenuse, and tangent as opposite over adjacent, because we were in a right triangle. The cosecants are still going to be the reciprocals. The reciprocal of the sine. Remember the opposite letter, S and C. You guys did great on the exam on this. The cosine will be the reciprocal secant function, and the reciprocal for its tangent instead of y over x is going to be still x over y. So how's anything going to change? Well, it's going to change just slightly. And so let's do an example. Let's do several examples and show you exactly how things might change. Okay. Remember what r is? R is a positive distance from the origin to your point on your circle. So it's the radius of your circle. Suppose 4 comma negative 4 is a point on the terminal side of your angle theta. Find the 6 trig functions of theta. So this actually came from our test. You were asked to plot the point 4 comma negative 4, going on the x-axis 4 spaces and then 4 spaces down. You guys did a great job on this, on your exam. I want to draw it in standard position. So that means I need and I asked you to do this in colored pencil, and some of you chose to do that and some of you didn't, and I was still able to figure it out. But your positive x-axis should have contained a ray, which meant I was looking for arrows. And your terminal side should have contained the point P. I needed the positive angle representing theta, and theta actually ended up taking you into quadrant 4. Now, you were not asked to find the trig ratios here. On your test, you were just asked to graph that in the coordinate plane. So that's what the answer is for your test. Now, to locate the sine of our angle theta and the cosine and the tangent with our old definitions of y over r, we first of all have to figure out what r is. Well, r happens to be part of the equation now. Instead of the distance to that point, we're going to call it r as a radius of our circle. It's still the distance. If we were to draw a right triangle, which was what most of you did on your test, you kind of drew a little right triangle there. And then you were able to do whatever you needed to do from there. So the sine of our angle theta, first of all, we had to find r. In using the equation of a circle rather than the distance formula, I'm going to take x squared plus y squared equals r squared, taking 4 squared and negative 4 squared equaling r squared, taking 4 squared, which is 16, and adding negative 4 squared, which is 16, and 16 and 16 add up to 32. Taking the square root of both sides, I'm putting a plus or minus sign, because I always do put a plus or minus sign when I solve my quadratics. But I do realize that r has to be a positive distance, since it's the distance from the origin to my point. And so I just incorporate the positive answer. R happens to be 4 radical 2. Going back to the definition of sine of theta as y over r, the y value is given to be negative 4 here. The r value is 4 radical 2. The 4's cancel to leave you negative 1 over radical 2. We don't leave radicals in denominators, and so what you do is you rationalize and you get your final answer of negative radical 2 over 2. The cosine of the angle, and you did not have to do this on your test. All you had to do on your test was calculate the distance here, which should have been 4 radical 2. The cosine of the angle is always defined to be x over r. Our x happens to be 4. Our r is 4 radical 2. The 4's canceled to leave you 1 over radical 2 positive. And then when we rationalize that, we get positive radical 2 over 2. The tangent is defined to be y over x. Your y value is negative. It's given to you as negative 4. The x is positive 4. When you reduce that, you get negative 1. Your reciprocal functions are just the reciprocals of, I'm going to reciprocal my sine here to give me my cosecant. I'm going to reciprocal it right here because I don't feel like reciprocating it here. If reciprocating is a word. Okay, so let me go ahead and grab my negative radical 2. The reciprocal for 1 over radical 2 is just radical 2. And the reciprocal of -1 is -1. And what I have is I have my 6 trig functions for my angle theta, which is not in a right triangle. My angle theta, by the way, my angle theta, for those of you who calculated it, was 315 degrees. How did we get that? How did you reason that? Most of you actually ended up drawing a right triangle here, which this was 4 and this was 4. And you then realized it was an isosceles right triangle. So this angle must have been 45 degrees, but my angle theta had to be 315 degrees. So congratulations if you did get 315 degrees for that angle theta. And again, I think most of you reasoned it because when you drew this right triangle, this leg was 4, this had a distance of 4, and this was 4 radical 2, and it just looked like a 45 right triangle to you. Now, I want you to realize that, as example 1 does illustrate, trig functions now might be negative. In fact, trig functions might even be 0. They might even be undefined. In this particular case, you've got your sine value of your angle theta being negative and your cosine being positive and your tangent being negative because of the placement of the point for -4. Example number 2, suppose that -5, 0 is a point on the terminal side of angle beta. So I've changed my angle. And so it says find the 6 trig functions of angle beta. So first of all, I'm going to actually plot the point. And the point is -5, 0. So I'm going to go ahead and draw my circle. I'm going to have my circle be a radius of 5. Because I want my point to be on that circle, because I'd rather use x squared plus y squared equals r squared instead of the distance formula, although I'm not going to do that either. In graphing my angle in standard position, I put my positive ray on the x-axis. It's not really a positive ray, it's more like an initial ray. And my terminal ray is actually going to be, oh, this is kind of like really weird, huh? My terminal ray has to contain the point -5, 0. And we end up getting our angle of rotation to actually be an angle that we know actually, we knew the angle in example 1 also. Some of us knew the angle in quadrant 1, in quadrant 4, the example 1. We actually know that this representation for beta could also be said to be 180 degrees. In looking at the sine of beta, and again, I can call this a sine of 180 degrees because of the termination at the point -5, 0. The definition for sine is that it's the y value over the r. The y value is 0. The radius of my circle happens to be 5. And so when I take 0 and I divide it by 5, I end up getting 0. The cosine of beta, and again, I could write this instead of beta, I could put cosine of 180 degrees. I could also put cosine of pi radians. I probably should have done that, but I didn't. The cosine of 180 degrees is the x over the r. The x is -5. And my radius of my circle is still 5. And so I get that reduced to -1. The tangent of beta is still defined to be y over x, not in a right triangle anymore. but I'm going to say it's tangent 180 degrees. It's another way to represent it as y over x. My y value was given to me to be 0. My x value is -5. Taking those and dividing, I get 0. The reciprocal functions are a little bit, might be confusing to you because the reciprocal of 0 over 5 is 5 over 0, but that's undefined. The secant, well, the reciprocal of -1 is just -1, so that's not confusing. But the reciprocal here, the reciprocal of the tangent of beta or the tangent of 180 degrees, the cotangent of your 180 degrees is, oops, -5 over 0, which is said to be undefined. So we always simplify our fractions. Rationalizing sometimes might take place. And of course, zeros and denominators are undefined. Example 3. Suppose that -5, 12 is a point on the terminal side of angle alpha. Find the 6 trig functions of alpha. So I don't have a circle drawn here. I wonder if I could drag this circle down. Let me copy this circle. I'll try it. If I copy this circle, though, I think my x and y axis disappear on me. Format that. Okay. So I want the point of -5, 12 on the terminal side of my angle theta. Let me go ahead and draw my angle in standard position, starting with my initial ray on the positive x-axis. But I need my point -5, 12 labeled, and I don't have a grid piece of paper here, but I'm going to assume that -5 is this way, and 12 is pretty far up with respect to my location. So x is -5 and y is 12. I'm going to say it's located right there. That's my point P. Let me call that point P. Again, I located it without graph paper, about -5 and up 12 spaces. I need my initial ray. I also need my terminal ray. So let me move this down here. One terminal ray move. There we go. And I need my angle alpha. And the rotation here, which I don't have drawn, we go from here all the way to there. So just go ahead and make a little arrow, very similar to this one. I think you have the idea. Alpha, where are you? Okay. I'm not sure if you know what R happens to be, but most of you are pretty great and say you love 5, 12, 13 right triangles. But you know what? I'm really not in a triangle anymore. So what do? I'm going to go ahead and do this on a whiteboard, and I'm going to go ahead and share a whiteboard with you. My point, negative 5, 12. I've got my angle in standard position. If I consider x squared plus y squared equals r squared, which is the equation of a circle with a radius of r, and I take the x value and square it, and my y value and square it, I get 25 plus 144 to equal r squared. R squared is 169. When I take the square root of both sides, I'm actually not going to put a plus or minus because I know the r, the radius of my circle, has to be positive, and I get r to be 13, just like when you had a right triangle, but we're not in a right triangle anymore. Our angle theta is more than 90 degrees. Again, looking at our angle alpha, which I drew so nicely for you in your notes, negative 5, 12 is up here quite high. And our angle alpha is more than 90 degrees. But don't be sad, okay? We can still find the trig ratios if we understand the sine is the y over the r value, the cosine is the x over the r value, and we have the x, we have the y, we've got the r also, and we've got the tangent of our angle alpha to be y over x. So if we just substitute these numbers in, and let's see if we have to do any reducing here, our y value was 12. Our r value was 13. Our cosine is x over r. Our x value is given to be negative 5. Our r is 13. Tangent is the y value, which was given to you to be 12. Our x value of negative 5. I am not fond of leaving negative signs in denominators, so I would rather write this as negative 12 over 5 or as negative 12 over 5. And again, I don't leave negatives in denominators for the most part. The reciprocal of the sine function is the cosecant. Make sure you put your angle on your trig ratio. And instead of 12 over 13, we'll put 13 over 12. The cosine's reciprocal is a secant. Put the secant of alpha. And instead of putting 13 over negative 5, since again, I don't like leaving negative signs in denominators, I'm going to write this as negative 13 over 5. The reciprocal of the cotangent, the reciprocal of the tangent is a cotangent function, cotangent of alpha. And instead of writing this as 12 over negative 5, I'm going to write it as negative 5 over 12. And that's how we write our trig ratios when our angle is not in a right triangle. It's still, the sine is y over r, the cosine is x over r, and the tangent is y over x. And let me go back to my notes. In the trig definitions, R, remember, R is the distance from the origin. Is always positive. If the sine of theta is y over r happens to be negative, then the cosecant is also going to be negative. And again, we just showed that in the example that we just did. If our sine is negative, then its reciprocal must be negative. Just think about it. So what quadrant or quadrants does theta have to be in for them to both be negative? So I want to first of all look at the sine and the cosecant. Remember, the sine is the y value over the r, and I want to know when both the sine and the cosecant will be negative. Well, the sine is going to be negative only when the y's are negative, because r is always positive. So y over r, when your y is negative, that would be in quadrant 3 and in quadrant 4. Those are the y-axis, where the y-axis is negative. The cosine and its reciprocal, the secant, are going to be negative whenever the x's are negative, and the x's are negative right here along this x-axis. The x's are negative in quadrant 2 and quadrant 3. The tangent's negative. Well, remember, the tangent is y divided by x. That means they have to be opposite in sign. One's positive and one's negative. And that will happen in quadrant 2, where the x's are negative, but the y's are positive, or in quadrant 4, because the x's are positive and the y's are negative, and that would make your tangents and your cotangents negative. I'm now going to go to what some people call an acronym. Let's go to whiteboard. And let me clear this. And go to the acronym that all students take calculus. All students take calculus. Take calculus. And this little rhyming, I guess it's not an acronym if all students take calculus. Knowing x's and y's in quadrant 1 are positive. All of your trig functions in quadrant 1 are positive. I mean, we just took a test on it. All of our trig functions in our 90-degree right triangles were positive. But once we get into plotting points in quadrant 2, where the x's are negative and the y's are positive, the only one that is going to be positive out of our three, and I'm talking about our basic trig function, our basic trig functions, the sine of theta, the cosine of theta, and the tangent of theta. Their reciprocals are going to have the exact same sign of them. So I'm talking about positive. Here, the y values are positive, so the students here, this is where the sign is positive. The take, the t, is from the point in quadrant 3 where both your x's and y's are negative. And when you take a negative and divide it by a negative, you get a positive. So the only ratio, trig ratio, positive in quadrant 3 will be the tangent or the cotangent. The y values, the sines will be negative, the cosines will be negative. And the calculus here stands for the cosine function. The cosine is going to be the only trig function positive in quadrant 4. the x's are positive here and the y's are negative. So when I take a ratio for my tangents of y over x, this will be negative. If I look at my sine, which is this over r, it will be negative. All students take calculus is one way to think of all positive trig ratios for sine, cosine, and tangent. All positive here. Sine will be the only one that's positive here. And of course, it's reciprocal. The tangent function is positive and the cosine function is positive. Now, taking that in mind, we're going to be looking at a problem that, see if you understand this concept. Going back to the notes. I have 3 problems here for you to think about. I want you to go ahead and look at these, pause the video, see if you can identify, and I'll read the problem with you. In the figure shown at the right, the cosine of theta is -5/6. Which angle or angles could represent theta? Angle POE, so angle POE, angle POD, angle POC, there's O to C, POB, remember we named this with 3 letters, POB is this quadrant 2 angle, POA is in quadrant 1 or none of those. I want you to go ahead and see if you understand the concept of all students take calculus. Okay, moving on. Hopefully you have your, stop the video when you've got your answers here. Okay, we've got the cosine being negative. Now, remember here's all students take calculus. The answer cannot be POA because your trig ratio is negative, but it's a cosine being negative. So the cosine is negative in quadrant 2 and in quadrant 3. Those are where the x's are negative. So that means that you're going to put an answer of POE. And you're also going to put an answer of, POC, right? Oh, but wait a minute. I didn't say the cosine was negative. I said the cosine was a value of -5/6. And what that does is that narrows down your choices. There's only 2 possible choices, but there's only one real answer for this problem. So if you've got the answer of POB or POC, and you put both of them, congratulations, you're almost right. But there's more than this value being negative. It's the value of 5/6. Remember, the cosine is the x value over the r value. The x is rather large. The x is 5, or you can consider the x as -5, as compared with the radius of the circle, which must be 6, x over r. So in looking more carefully at our angle POB versus POC, in looking at this x distance and this y distance, I think you can see that this x distance is very short considering this y value here and a radius of 6. If you were to draw a right triangle right here, I do not believe that this x value could possibly be a distance of 5 because that point B is so high in quadrant 2. But if you consider the other possible negative cosine value, and you look more carefully at angle POC, this x distance looks like it could be 5. And remember, this r happens to be 6. That's the radius of your circle. And this x value does look like it's actually rather far over, very close to that same value. So of 6. So 5/6, that ratio is much better represented by angle POC than it is for angle POB. Okay, now that we've done that, I want you to just pause the video and try number 2 and try number 3 and see which ones make more sense to you now. Looking at not just the negative on these, but the value of 5/6. Okay, hopefully you've got this idea down. The sign is the y over the, well, if sign's negative in which 2 quadrants? Okay, the sign's negative in quadrant 3 where the y values are negative and in quadrant 4. But most importantly, we want the sign to be -5/6, not just negative. So we've got 3 angles here, POC, POD, and POE. Maybe all of them, maybe none of them. I'll see. Well, let's look at the y over the r. The y value is 5 as compared to the radius of 6. So let's look at the y value on the angle in quadrant 3, which is POC. Angle POC, okay? Do you think this y value is 5? I don't think that y value is probably close to 1 maybe, or 2. If this is a radius of 6, this y value is not very far. So I'm going to say POC can't possibly be the answer. The y value is not large enough. Okay, then we've got POD versus POE. Let's look at POD first. POD. Looking at this y value, looking at this y value, does this y value appear to be the correct one? Or looking at POE, does this y value appear to be 5? This y value? Or this y value? Well, if our radius is 6, this y value looks to me to be 5/6. Okay, so I've got, let me see, POD is my answer. And again, we can discuss this during office hours if we need to, if you don't quite understand the values, not just the sign of the trig ratio, but the value. Okay, for -5/6, I got the answer. Remember, this is y/x. This does not have anything to do with the radius of the circle. It's just a y over an x value. And I'm looking at, okay, first of all, being negative, the tangent is negative in quadrant 2 and quadrant 4. All students take calculus. Tangent's positive here and everything's positive in quadrant 1. So tangent y value over the x value. So looking at this, do you believe this y value is 5? And this x value is 6. Well, to me, it appears that this x value is much smaller than that y value. So I'm going to throw out POB. I'm going to throw that one out. Okay, let's look down here. This, what am I looking at? Y/x. Does this look like this is y is 5? And this x value, does this look like it's 6? Not to me. Okay, we only have one more choice, this one. Does this look like this has a y value of 5? Oops, don't want to move a y value of 5 and an x value that's a little bit longer than that. Yes, to me, that appears to be angle POE. So hopefully you got those answers. How about capital letters here? POE. Push the cap button. Okay, example 4. Moving on. The cosine of delta is 4/5. Find the remaining trig functions of angle delta. Well, if you look at your paper, I've got 2 pieces of graph paper here. And why would I have 2 pieces of graph paper? Because the cosine is positive in 2 different quadrants. The cosine is positive in quadrant 1. Everything's positive in quadrant 1. But the cosine is also positive in what quadrant is that? Oh yeah, that's quadrant 4. I'm going to go ahead and do this on a whiteboard, and I'm going to do this all at once on a whiteboard. So let me go ahead to the whiteboard. Cosine of delta is 4/5. So I'm going back to my quadrant 1 where cosines are positive and everything's positive. Cosine, cosine is my x value over my r value. Oh, look, I see a 3, 4, 5 right triangle. Do you see that? 3, 4, 5 right triangle. Can I find all my trig ratios? Absolutely, I can. In fact, you've been doing this like forever. You can find all trig ratios right there. But you have to realize that delta could be, because it's also positive, when this is 4. Let me make that look like it's more. Okay. I just want to make the ratios look a little bit more like this one, which looks like my sausage right triangle. Oops, I do not want that. I want my hypotenuse to be 5. But because I'm actually terminating in quadrant 4, this distance, if I were to label this point P, would be negative point P. Would be -3. I'm sorry, the mess I have there. Let's erase everything. Okay. My x is still 4, but my y in this case has me terminating in quadrant 4. There's the sweep of my angle. Giving me some different trig ratios. So while I'm positive that you could do quadrant 1 angles, quadrant 1, because you did so well on your test on these 6 trig ratios, the sine of delta is 3/5. The tangent of delta, and again, you can look at this as a right triangle because you're in quadrant 1 and you have acute angles here, as your y over your x of 3/4. And of course, you have your reciprocal relationships. But what happens if your delta terminates in quadrant 4? What's changes? What's different? Well, the cosine is still 4/5. Cosine delta, make sure you put your angle on your trig ratios. But what's your sine value? Your sine value is the y over the r, and the y is now -3/5. So my trig ratios have the same fraction, but they differ in signs. Tangent of delta being the y over the x. Got my y value there, got my x value there, -3/4, as opposed to a +3/4. So, and again, your reciprocal functions, your cosecant for delta would be -5/3 reciprocal. Your secant of angle delta is 5/4. And your cotangent delta being -4/3. Okay, let's move back to the notes. What are the possible values for angle delta in example 4 above? Oh, you know what? I wanted to show you something else on example number 4. Let me go back to that whiteboard. Because the way I do it normally, like if I were doing this on my homework, I wouldn't do it this way. What I would do is I would use the cosine squared of delta added to the sine squared delta. It's the most important identity in trigonometry. You know it's 1. You know it's 1. Cosine squared delta plus sine squared delta, you know it's 1. The cosine given to you is 4/5 could get squared. Four over 5 squared is 16/25. Subtracting that from both sides, I'm going to get a common denominator here. It's what I do. Subtracting 16/25 from both sides gives me sine squared delta equals 9/5. I'm sorry, 9/25. Now, when I square root both sides, I don't forget to put a plus or minus because my sign can be negative. My sign can be negative. It can be positive. It just depends on what angle my delta terminates in. So sometimes when I'm doing this, it helps me remember to keep the plus or minus. Otherwise, I might just go ahead and accidentally only put quadrant 1 when there's actually another quadrant in which the cosine happens to be positive. Okay, now it says we'd like to find out what delta is. So we don't know the exact value of delta, but we know that the cosine of 45 degrees, you know, we all got this right on the test. It's so amazing. Okay. The cosine of 45 degrees is radical 2/2. But we don't really actually have, in most of our minds, we don't actually know what radical 2/2 is as a decimal, but it's approximately, I believe, 0.707. I'm going to go to a calculator here in a minute. 0.707. So I'm thinking that my angle for this triangle, I mean, if this was a 4 and this was a 4, right? If this was a 4 and this was a 4, I'd have an equilateral right triangle. And so I'd have my square root of 2 over 2. But I believe that this angle is probably smaller than 45 because this height is smaller than 4. So I'm going to say, I'm going to guess that, okay, I don't think that's a 30-degree angle because the cosine of 30 degrees is radical 3 over 2. I think I've got a song for that. Okay. But this is approximately, I don't know exactly what it is, but approximately maybe 866. And our cosine right here is 4/5. The cosine of our delta is 4/5. And 4/5 can be written as 8/10 by multiplying the numerator and denominator by 2. And that's 0.8. So I'm pretty sure that my angle is somewhere between 30 degrees and 45 degrees, but I'm not sure what it is. So I'm going to go to a calculator and I'm going to guess. Okay, so let me go to a calculator. Cosine of somewhere between 30 and 45. So here's where if we were in class together, I'd be saying, hey guys, guess me an angle. Okay, so let me clear my calculator here. This is a Casio online graphing calculator. I'm going to go ahead and exit here and go to exit there and delete everything that I was working on. Okay, so let's see. A cosine of 30 degrees. Cosine of 30 degrees, if you haven't got a clue, the cosine of 30 degrees is radical 3 over 2. If you want the decimal approximation on the Casio, you go fraction to decimal key. It'll give you that 0.866, 0.866. But I don't want, I think I need a cosine of, let's say 35 degrees. Let's let that be our guess. Ooh, that's too much because we want 0.8. So how about cosine of 40 degrees? Ooh, that's too small because we want 0.8. How about the cosine of 30? What do you think? 38 degrees? Oh, that's not big enough. We could be here all day long guessing. So what would be, or what is the appropriate way of using your calculator on this? The appropriate way of using your calculator would be to go shift cosine parentheses, and I can use a fraction key because I've got one, 4 over 5. And this is saying, this is actually going to give you the angle where the cosine is 4/5. And the answer is about 36.869899. Okay. 36.86989765 degrees. Now, I'm not fond of anybody rounding off decimals. If that's what the calculator says it is, that's what the answer is. And you shouldn't put 37 degrees, about 37 degrees. It's not the answer. The answer is 36.86989765 degrees. For those of you new to the class, Comey does not like you rounding decimals off. Now, I would like to show you something that I haven't shown you before, though. It's kind of nice to have. I would like to change this decimal degrees into degrees, minutes, and seconds, but I'd like to use my calculator to do that rather than doing it by hand like you had to do on your test. So I'm going to go to Option. I'm not going to go to matrices. I'm not going to do calculus. I'm not going to do statistics. I'm going to do more. I'm not going to connect hyperbolas, probability, and angles. There we go, angles. watch this button right here. This button right here, watch. I'm going to click it. That answer is 36 degrees, 52 minutes, and 11.63 seconds. Again, I could go back to the decimal, 36.86989,765. I could convert it by hand if I really needed to, but I don't need to when I've got this calculator. And I do believe that the Texas Instrument does not have that key on it. 36 degrees, 52 minutes, and 11.63 seconds is much nicer than, in my opinion, than that terrible decimal. However, we got a problem. The calculator only gives you, when you use this inverse button, the calculator only gives you one answer, and we know there's two answers. We know there's an answer in quadrant 4. So what you have to do is understand the relationship. How do I get from quadrant 4 to quadrant 1 to quadrant 4, because cosine's positive in quadrant 4. What we do is if you take 360 degrees and you subtract the answer, that'll get you into quadrant 4. So the answer is 323.1301024 degrees. Or if you'd like to put that in degrees, minutes, and seconds, 323 degrees, 7 minutes, and 48.37 seconds. Thank you for doing a really good job on the converting and adding and stuff like that on your test. You did a great job on that. But it's so nice to have the calculator option if you knew it existed. So those are the answers for delta from 0 to 360 degrees. Now, let me go back to the notes. Okay, I'm going to call this 36 degrees right here, or almost 37 degrees, but I'm going to call it 36 degrees for just a moment. So I want to show you something else you can do. Now that we know that this angle is about 36 degrees, we could also say that this angle is the negative 36 degrees, right? And then we don't have to go all the way around to quadrant 4 in this direction. But most of the time, the directions in your book are going to say they want delta to be between, or to be in the interval between 0 and 360 degrees. So what's that's going to do? That's going to rule out the fact that you can't just put it, if this is 36 degrees, you can't just put negative 36 degrees and get down here. Although that's a correct answer, that's not an answer that's in an interval that might be given to you. Okay, and most of the intervals are from 0 to 360 degrees because we like going in positive directions rather than in negative directions in most situations. Okay, so okay, going back to the notes. Okay, so we explored. Okay, and I think I put from what I did here is you use the cosine key, you shift cos backwards. So filling in these blanks, this is just what I had said while I was at the whiteboard. Push shift cos, then put in your trig ratio 4/5. The calculator only gives you this one answer. And again, you could go ahead. These are in degrees. Make sure you put degrees, don't put 36 radians on that. That's a long way around the circle. Important facts. There are some other identities that follow immediately from our new definitions of the trig functions of the circle, and from the fact that the terminal side of a negative theta is a reflection of the terminal side across the x-axis. So here's what I'm talking about. If this is a positive angle theta, negative theta, this angle represented in standard position of negative theta, is just a reflection across the x-axis. And again, I think I've got it down here, the same thing. If this is theta, negative theta is represented by this x-axis. If I move this, and I put theta in quadrant and I put theta in quadrant 3. I put theta in quadrant 3. Negative theta is a reflection over the y-axis. Negative theta would be up here. Oops. Negative theta would be up here, just be reflection over the axis. So we have the cosine and the sine and the tangent of a negative angle. Don't think of that as negative theta. Think of it as a negative angle. The cosine going down, the sine going down, and the tangent going down. How are they going to be related to the angle in a positive direction? Well, if you consider that the cosine in quadrant 2, and you consider a point up here in quadrant 2, what is the cosine reflected down here? Let me go to whiteboard and try to explain this more clearly. If I have theta ending up in quadrant 2, that means I must have had a point on the terminal side that had a negative x and a positive y value. That's how points are labeled in quadrant 2. Duh. Well, what happens if my angle theta is a negative theta? What does that do for me? That puts my, instead of being in quadrant 2, that puts me in quadrant 3. That's how negative angles are drawn in standard position, where the x's are negative and the y's are also negative. So looking at the cosine of an angle going down, the cosine of an angle going down is exactly the same as the cosine going up. They're both negative x over r. It's the same as the cosine going up. However, the sine of the angle going down, the sine of this angle going down is negative y over r. And the sine of the angle going up see the sine of this angle? That's y over r. Those are not the same. Those are opposites of each other. Same thing with the tangent. The tangent of an angle going down, and in this case, the tangent of this angle is this value over that value. But the tangent going up, that positive angle, this tangent here is y over negative x. And these are not the same. So the only trig function that'll give you the exact same answer going up and going down is the cosine function. And I think you saw this when we had cosine of theta, or cosine of delta being in quadrant 1 is 4/5, and the cosine going down here was also 4/5 in quadrant 4. So how do we write this? We write this as a sine because I don't have this in my on my notes here. The sine of negative theta is going to be equal to opposite of the sine of theta. So let me go to my notes and see if I can put that in there. Okay, so the cosine going down is exactly the same as the cosine of theta going up. Just copy that angle. But not so for the sine. The sine is going to be the opposite of the sine going up. And again, the tangent is going to also be the opposite of the tangent going up. So you can think of it as a negative angle, or you can think of it as an angle going down. And those are what we call identities. And we're going to be using these identities in the next couple of days. Okay, so we've got our angle going positive direction and an angle going in a negative direction, which I did on the whiteboard. Okay. Find the 6 trig functions of an angle theta of 270 degrees. I'm going to do this on a whiteboard. $270 degrees. Well, first of all, I need to know how to draw an angle 270 degrees in standard position. I have my angle, which I will call 270 degrees. I could call it theta, but I might as well call it 270 degrees. It makes a sweep this way. So the initial side is the positive x-axis, which nobody seems to want to mark because I always mark the positive x-axis for you. But you need the negative y-axis down here. It's pretty, I can do better than that. I can do better than that. Draw a nice y-axis here. I need a point, which I call point P. And I can call any point I want. So I would ask somebody in class and they would say, hey, x is 0 and this y value is, let's say it's -6. It's a nice number. Well, then I would ask you, this is the x value and this is the y value, then what's the r value? And you'd have to say the distance from the origin, the distance from this point to there has to be distance of 6. Well, that's going to give us our 6 trig ratios. As long as we know the sine is the y over the r, the cosine is the x over the r, and we know the point you gave us. And the tangent is the y over the x. So the y value in this case, at this point right here, is -6 over r, which is 6. So this reduces to -1. The cosine is the x over r, which is 0. And the tangent is the y over the x. Oh, that's not good. Why is that not good? Because you can't divide by 0, we say that's undefined. So the tangent of 270 degrees is said to be undefined. What about the reciprocals? The reciprocal for the sine of 270 degrees would be the cosecant of 270 degrees, and the reciprocal, this is just 1. The cosine's reciprocal is the secant. The secant of 270 degrees is 6 divided by 0, which is undefined. And the cotangent of 270 degrees is 0 divided by -6, which is 0. So those are the 6 trig ratios. Now, in your notes, I say, why do some people in mathematics say they, instead of liking 0, -6, they would like us to go to a circle that has a radius of 1, which means just go down to 0 and -1. Just go to a distance of 1. Don't just take any point. Take a point on what's called the unit circle. U-N-I-T. Unit circle. Well, let me try to explain to you why they do this. It's because the sine of the angle is defined to be y over r. And if you let r be 1, then all you have to do is look at the y value of your coordinate. Now, this unit circle doesn't work well unless you're on a radius of 1 and quadrantal angles of 270, 90 degrees, or 180. Remember going back earlier, we did an example where the cosine of delta was 4/5. Well, you can't assume that that has a radius of 1 because it actually has a radius of 5. But because we've got this 270 degrees or 180 degrees or 0 degrees, some people say, what happens if we just go ahead and take any point we want on the x-axis or the y-axis and call it 0, -1, then our cosine will just be the x value that you see. So you might hear, if you go to the STEM Center or the Math Learning Center or go to a tutor, you might hear people talk about, well, do you know about the unit circle? And you go, oh, not really. But the unit circle means we're just going to let r be 1 when we can. And it's mainly for these quadrantal angles if we can. And if we need to evaluate the trig ratios, it's much easier. Instead of saying -6/6, if this r is just 1, all you have to do is give me the y value. Oh, actually, I think I have made a mistake there. It should be -1. Okay. And just give me the x value, because I'm just putting a 1 down here. And this one, though, I still have to do the division. The y would be -1/0, which is undefined. So it just says sometimes it's convenient to let your radius be 1 to evaluate these quadrantal angles of 90 to 70, 180 degrees. So let's go to your notes and see if I can explain what I mean when I say a little cheating chart. So remember, in our cheating chart, what we want to do is just consider that we're going to have a radius of 1 right here, and we're just going to consider a radius of 1, and we're going to consider points on the x-axis and points on the y-axis 1 unit away. So if I want the sine of 90 degrees, I know that 90 degrees terminates up here. And I go, well, if I were going to label this point up here 90 degrees, I would say that was a y value of 1. And so that's my answer. The sine of 90 degrees is 1. And I don't do any other calculations other than looking at my y value. The cosine of pi over 2, well, pi over 2 is the same as 90 degrees. It's just a different language. It's radians. And so if I look at the cosine there, well, what would the x value be if I'm on my y-axis? Actually, anywhere on my y-axis, it would be 0. But particularly nice if it's 0 divided by 1. Or 0 divided by 2, 0 divided by 3. It's all going to be 0. The tangent in 90 degrees, if I labeled a point here like 0, 1, the tangent is the y over the x, or the 1 divided by 0, which is undefined. And I kind of call this a cheating way of doing it because you're not drawing a y over an x or a y over r. But again, these are all quadrantal angles. Let's go back to 270 degrees, which we just did. 270 degrees, going this way, 270 degrees. Well, what's the y value way down there on a circle of radius 1? That y value would be a -1. The cosine at 270 degrees, the cosine, the x value there is 0. And again, I hope you can speak both languages. 270 degrees is the same as 3 pi over 2 or 3 over 2 pi radians. The tangent is the y value over the x value. Or remember, it's the sine over the cosine. We had that identity before. The sine over the cosine. And -1 divided by 0 is undefined. So, and again, we're kind of cheating because we're really not doing any math. We're just looking at a point on the x or y axis. Okay. So sine of pi, remember what the pi happens to be same as a 180-degree angle. Again, these are all quadrantal angles. Over here, what's the y value on the x-axis? Which is 0. Didn't move up, didn't move down. The cosine over here, the cosine on the circle, located on that negative x-axis, -1. The tangent is the sine divided by the cosine, and 0 divided by -1 is 0. The cosine of 2 pi, 2 pi radians, that's 2 times 100, that's all the way around the circle. And what's the cosine right here on your circle? What's the x value? It's going to be 1. Maybe I even have a song for that, but we'll have to wait till tomorrow for that. Exploration number 2, if you figure out what was exploration number 1, because I never really did discuss it as exploration number 1. Exploration number 1 right here, when I did it in our notes, the cosine is positive in quadrants 1 and quadrant 4. Filling in the notes. So there were 2 answers. And we explored that in the calculator by guessing. I think we guessed at 30 or 40 degrees. I think we guessed at maybe 38 degrees. And then we went to the calculator. I didn't fill it in on these notes. 38 degrees, I'm not sure what we got, but then we put in the calculator and we got the real answer to it. But so this is exploration number 2. And it's called, I want to look at the tangent where the tangent happens to be -2. So again, you're going to do the same type of process in your calculator, but you need to understand the tangent is negative. All students take calculus. The tangent is negative in quadrants 2. And again, we use Roman numerals for that, or quadrant 2 and in quadrant 4. So again, there are 2 answers, and the calculator is only going to give you one of those answers. Use a tangent key backwards. You're going to push Shift tan. Then you're going to put the -2 in. The calculator is only going to give you one answer. So I put the tangent of 45 degrees here is 1, just to make sure I was in degrees. When I do the inverse tangent in -2, I get -63 degrees, about -36.43494882 degrees. I could change that to degrees, minutes, and seconds. But most of the time, it's not going to give you an answer between, this says to give me an answer between 0 and 360 degrees. So I've got an angle that's negative, and all I have to do is figure out how do I terminate? I mean, how do I make sure I'm in the right quadrant, but I have positive answers only? And again, I think most of you has mastered this concept. But just to review, we've got to have two answers. And so I'm going to go ahead and go to the whiteboard, and then I'll probably go to the calculator also to show you what to do. Okay. I can't remember what angle I called that. I'll call it tangent alpha equals -2. It could be theta. I don't remember right now, and that's okay. So I'm going to go ahead and say that alpha is, I'm going to say about, it was about -63 degrees, I believe. Actually, I guess I should check that out. Let me go check that out. Putting rays here, putting my sweep, right? So this angle right here gives me my angle in quadrant 4, but it doesn't give me, I guess that was a theta, okay. Because I wanted theta between, in the interval between, that's as an element of 0 to 360 degrees. This is usually an epsilon, notation wise. What's going on here? Epsilon between 0 and 360 degrees. Don't do 360 radians, or we'll be here all day long getting all those angles. Between 0 and 360 degrees, and our answer is negative in the calculator. So what we have to do is we have to realize, well, how do I terminate and get in the same place? I either add 360 or I subtract 360 to get in the same place. So if we take 360 degrees and subtract this answer, that'll give us our angle, but it'll only give us our angle theta in quadrant 4. We also need to get the angle in quadrant 2, where the tangent is also negative. And so we do that by adding 180 degrees or subtract, well, we need to add 100. If we subtract, we get a negative answer. If we add 180 degrees, that'll put us, if we add 180 degrees to this, that'll put us in quadrant 2. So let's go to the calculator. Okay, so I'm going to go ahead and go Shift tan. Nice to do the right function. Shift tangent -2. Give me that angle. Oh, look, degrees, minutes, and seconds. There's my angle in degrees, minutes, and seconds. But I want to add 360 degrees to that to be in the domain that they gave me, which is 296 degrees. And that'll get me my quadrant 4 angle. Oh, there it is. 296 degrees, 33 minutes, and 54.18 seconds. But I also can take the angle where the tangent is -2, and add 180 degrees to it. And that'll get me in quadrant 2 at 116.5650,512 degrees, or 116 degrees, 33 minutes and 54.18 seconds. Okay. Oh, almost done. While the domain of trig functions is a set of angles, the range is a set of real numbers. In advanced work, such as in calculus, it is necessary to modify the trig functions so the domain contains not angles, but real numbers, which means we're not going to have angles in degrees. We're going to have angles that are real numbers, like 2 pi, 3 pi over 2. Those are called real numbers. To do this, we need the relationship between an angle in degrees and an arc length of 2 pi on a circle. More to follow tomorrow, where we'll be working more on getting you prepared for calculus. So that's it for today. I will get this Zoom recording up as soon as possible, and I'm going to stop recording now.